We are recording. So I want to do with you exercise 84 that I remember that I skipped it because we didn't have the background at this time. But now we have it, so we can do it. 84. So let's say, refer to the exhibit. The exhibit shows a small switched network on the content of the MAC address table of the switch. PC1 have sent a frame addressed to PC3. The PC1 to PC3. What will the switch do with the frame? So here we have the CAM address table, the CAM table of the switch, or the MAC address table of the switch. So PC1 is sending a frame to PC3. So of course, the destination MAC is going to be the MAC of PC3. The source MAC is going to be the MAC of PC1. So the switch, as you can see, already learned that in port 1, it have a device with this MAC address, as you can see. It already learned that in port 3, it have a device with this MAC address, as you can see, no? So they say, what will happen with this frame? So the switch will learn if it doesn't know the MAC address. So this MAC address is not there. So the switch will learn. It will learn what? That this MAC address is connected on port 4. And then the switch have to take a decision. So it will add an entry, of course, here. Then the switch have to take a decision what to do with the frame. So we look at the destination MAC. This is the destination MAC. Do we have an entry already in the CAM for this MAC? No, I don't know where is this MAC. So since I don't know where is this MAC, I will flood. Flood means that I did receive the frame on interface 4, and I will copy the frame in all the other interfaces, which mean interface 1, 2, and 3. So let's see, the switch will discard the frame, which means that it will do filtering. It's not the case. The switch will forward the frame to all ports. It's not to all ports, no? Flooding is all the other ports. So it's not to all ports, no? The switch will forward the frame to all ports except for port. This is flooding because the switch received the frame on port 4. And if we do flooding, it will copy the frame in all the other ports. So this is correct. Let's see. The switch will forward the frame only to port 1 and 3. Okay, the switch, a basic switch never do that. A basic switch do filtering, which means it drop the frame. Flooding, I receive it on one port, I copy it in all the other ports. Or commutation. I receive it on one port and I copy it in another port. But never I copy it to 2 port or 3 port or 4 port. I never do that. Okay, a basic switch. Now, we have switches that are a little more elaborated. They might do that. Okay, but we have not seen that. The switch will forward the frame only to port 2. That will be, it will do commutation. This is not the case. It doesn't do commutation here. Okay. We have done those exercises, but not this one. So let's go over this one. Refer to the exhibit. It represents the network of a company that have 4 LAN. So let's see. There is a LAN here, a local area network. So LAN normally is associated with Ethernet, no? Ethernet, fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet. And we also have wireless LAN. When we have Wi-Fi, for example, here we have a wireless LAN. We have, where it is? Oh, it is there. We have a wireless router or an access point, might be an access point. And it gives a service here. So you connect your cell phone or any Wi-Fi device. This is a WLAN, wireless local area network. No? So here we do have a LAN. Here we have another LAN. Here we have a third LAN. And here we have a fourth LAN. Those are point-to-point connection between router using Ethernet. Okay, this is a point-to-point connection between, or back-to-back connection if you want, using Ethernet, no? Okay, so they say there is a LAN, I'm going to say LAN 4, okay? To be easier, LAN 4 is this one, as you can see, the one that is connected to Fast Ethernet 2.0. LAN 5 is this one, LAN 6 is this one, and LAN 7 is this one, no? So LAN 7, not to say 200.4.7.0/24, it takes too much time to say that. Okay, since it's a small network, the administrator is using static routing. Okay, so let us consider that the routing table of R1 is as shown below. So we have the routing table. What will router R1 do with a packet that is with a destination IP address 200.4.6.10? So let's say that I am R1, I'm this device, this router, and I receive a packet. And I look at the destination IP address, and the destination IP address, I have to forward this packet toward 200.4.6.10, which is toward network 6. So as you can see, network 6 is here. So of course, R1 should send it to R3. Otherwise, there is a misconfiguration, no? So let's see what will happen. So this is a routing table of R1. How many entries we have in the routing table? Eight entries, no? We count the number of S and the number of C. So there is 1, 2, 3, 4, 5, 6, 7, 8. So R1 will compare this IP address with the 8 network that it knows. So first it asks, is this IP address part of this network? Is it part of this network? Yes or no? No, it is not part of this network, no? Okay, the IP address that are part of this network start with 200.4.4 and something else. This one starts with 200.4.6, so it's not part. Is it part of this network? No. Is this part of this network? Yes, one match. But we keep going. Is this part of this network? No. Is this part of this network? No. 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 Yes. In this network, all the IP addresses are there. This is the default route. So there are two possibilities, this one and this one. When we have several possibilities, what will do the router? No. It will do a recursive search when the information is missing. For example, when I don't know what is the outgoing interface, I do a recursive search. But information, I cannot say at this point the information is missing because I have two entries, I have to choose one of the entry. When I choose one of the entry, if I don't have the output interface, I will have to do a recursive search. So now the first step is we have two hits. Two possibilities. We need to select one. Which one we are selecting? What is the criteria to select one over the other one? Yeah? Oui? Yeah, please repeat what you say.
The one that's closest.
The one that is closest? How do you know what is the one that is closest? Remember that the router don't have eyes. The router don't even have the graphics. It's not intelligent at all. It's very basic device and you have to tell the router everything. It's like a computer. A computer is not intelligent. You know that a computer is not intelligent. If you don't tell the computer, do that, do that, do that, it will not be able to do it. So the router is the same thing. The router don't even know what is, if you don't tell the router what is beyond its own interfaces, it doesn't know. So it doesn't know who is closer, who is further away. So when there is several possibilities, the router will choose the more specific network. The more specific network is the network that have a smaller number of IP addresses. So which network have a smaller number of IP addresses? This one or this one? Which is more specific? Which have the shortest subnet mask? (200.460), of course, have less IP addresses. It have how many IP addresses? 256. Now 0.0.0.0.04/0 have all the IP address that you can imagine, which is 2 to the power of 32. It's why we call it the default route. In case there is no other possibility, I will take it. You see, it's why they call it the default route. But if there is other possibility, I will never take it because it has all the IP addresses, the biggest network. And we always choose the more specific network, the smaller one. So the router between these two entries that make a match, the router will go with this one. So this one say what? Send it to 10.0.0.2. So send it to R3 at the end, no? Which is 10.0.0.2. So of course, the router now say, okay, I need to send it to 10.0.0.2. They didn't tell me what is the outgoing interface. So now I make a recursive search because I need to know which interface of my interface I have to use to reach 10.0.0.2. So the router now search again in this routing table which entry will make match with 10.0.0.2. So look at, is 10.0.0.2 in this network? No. Is it 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 here? No. Is it here? Yes. It is here. So our first match. Is it here? No. Is it here? Yes. We have two match. So the same thing. Which one is more specific? This one or this one? Of course, the first one. Remember, this is the last resort. The thing that I will do if I don't have choice. But if I do have choice, I will not use it. It's the default route. This one only have 4 IP addresses. This one have 2 to the power of 32. A lot of all the IP addresses of the world. So look at, if I want, if I take this entry say it is directly connected to fast Ethernet 00. So it say, send it out on fast Ethernet 00 to 10.0.0.2. So the router now have all the information after making a recursive search, and it will send it to R3. And of course, the routing table of R3 will say, oh, this device is directly connected to my 1 on my fast Ethernet 1.0, so I will forward the packet directly to it. I will not forward it to another router. I will forward it directly to the final, the end device. Okay? So this is what it will do. So what will I want to do with a packet that have a destination IP address 200.4.7.14? So we have the graphic. We can see the graphic. So of course, if we want to reach network 7, it should send it out this interface to 10.0.0.5. This is what we can see because we are intelligent. We have the graphic. The router don't have that. The router just have the routing table. and look at the routing table, and according to the routing table, decide. Okay, so the router say, okay, now I want to deal with this one, which is 200.4.7.14. So it starts. Is this IP address in this network? No. Is it in this network? No. Is it in this network? No. Is it in this network? Yes, a match, a first match. Is it in this network? No. 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 Yes, a second match. Of the two matches, what is going to decide? This one, of course. Why? Thanks to God, it doesn't decide the other one, because look at the other one. The other one send it to 10.0.0.10. Who is 10.0.0.10? The internet. So of course, if I want to reach a device here, I should not send it to the internet. Okay, otherwise it will never arrive. So it's why, thanks to God, it does not take the second entry. The second entry is in case you didn't find any other match, you go with the second entry. So it will take this one says send it to 10.0.0.5. We can see that 10.0.0.5 is our true because we have the drawing. We can see that it have to go out this interface, but the router doesn't know it. So the router just know that it have to send it to 10.0.0.5. It doesn't know which interface to use. So it make a recursive search, which is a second search. So it's look now for 10.0.0.5. 10.0.0.5 is not here. 10.0.0.5 is not here. 10.0.0.5 is not here. It is not here. It is not here. It is not here. It is here. And it is also here. Two matches. Of the two matches, it will take this one. And this one say it is directly connected, which means that 10.0.0.5 is directly connected on my fast Ethernet 1.0, which means that I have to send it out my fast Ethernet 1.0 to 10.0.0.5. And my job is end there. I don't worry more about the packet. I just forward it to the next hop, and the next hop will do the rest of the job. This packet finally will arrive to its destination. Okay, so now let's do this exercise. What will happen if I want to send it to 8.8.8.8? So R1 have received a packet, and the destination is 8.8.8.8. So where is 8.8.8.8? This is an IP address that you should know. It belongs to whom? To Google. It's a public DNS of Google. So it's very easy to remember because it's 8.8.8.8. So we can memorize this really easily. So of course, this company is not Google. Google for this company is the internet, is it? In the cloud. Okay? So of course, R1 should send it to the internet, not inside the company. This may be JSU. I'm not going to send it inside JSU because the destination is not inside JSU. So let's see what the routing table will do, what the router will do. So is 8.8.8.8 in this network? No. Is it 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 here? No. Is it here? No. Is it here? No. Is it here? Of course. It is always in the default gate, in the default route. So we have only one match. When we have only one match, we don't have a choice. We have to do what this match say. So this match says send it to 10.0.0.10. I just have the next hop. So I need to do a recursive search to get the output interface. So this time I search for 10.0.10. Not here, not here, not here, not here. It is here, one match. Not here, not here, it is here, a second match. Between the two matches, of course, I will go with this one. And this one say, oh, if you want to reach 10.0.0.10, it is directly connected on your serial 2/0, which means that I have to send it out my serial interface 2/0 to reach 10.0.0.10, which is the ISP router. Okay, this is my border router. They call it border router because it's at the border of my company, and it's connected on one side to my company, on the other side to the ISP. So I'm going to send it to the ISP. On the ISP, the router of the ISP will take care to forward it to another router, and by hop like that, it will finally arrive to the border router of Google, and it will enter the autonomous system of Google. When it is in the autonomous system of Google, the router of Google will take care, it's a big company, to forward the packet where it have to go, okay? In the LAN where we have the DNS server. Okay, let us consider the routing table of R1 as shown below. So it's not the same routing table. So as you can see, the previous one did have 1, 2, 3, 4, 5, 6, 7, 8 entries. This one have 1, 2, 3, 4, 5, 6, 7, but it also works. And you have another example where we have 1, 2, 3, 4, 5, 6, and it also works. Which means that the routing table don't have to be unique. Okay, we can make some optimization. So it say that, let me remove this part so we can see both. Okay, so let us consider the routing table of R1 as shown below. What will R1 do? Or before we do that, let me come back. So let's see that the routing table at the end was correct. So if you look at R1, it is directly connected to 3 networks. So we need C in the routing table. We need 3C. So let's see, we do have 3C. So for example, if I look at this network is the 10.0.0.0/30. It is directly connected on the fast Ethernet 0/0. So I need to see that in the routing table, it is there. Then for example, this network is the 10.0.0.8/30. It is directly connected on my serial 20. So I should see this reflected here, it is. And this network 10.0.0.4/30 is directly connected on my fast Ethernet 10. It is there, as you can see. Now, those appear in the routing table because the network administrator go inside the interface and type a command IP address. For example, for this interface, the network administrator type interface serial 2/0, enter. Then IP space address space 10.0.0.9 space 255.255.255.252. Then it type it no shutdown. So because it did that, there is an entry here in the routing table that appear with C. Now, all the one that appear with S is because the network administrator went to the router and type command IP route. So of course, for example, if the network administrator want to tell R1, this network exists, the network 6 exists, it have to type a command in R1. So this command could be, we have several possibilities, no? So this command could be, for example, IP route, the network is 200.460.255.255.255.0, and just specify the next hop, for example, which is 10.0.0.2. This is exactly what the router, the network administrator typed in here, because I can see this entry. Another possibility is that the network administrator type a very similar command, but help a little more the router. And tell the router, okay, go out, fast Ethernet 0/0. So this is another possibility. There will be no recursive search toward this network, this remote network. Okay, so I need to tell the router. The router will not know if you don't tell it. So this is static administration, static routing. Now we can define also dynamic routing, where we run processes inside the routers. The processes talk to each other. The router exchange information and they learn about remote network because they talk to each other. Okay, so if we use RIP, Routing Information Protocol, or OSPF, or EIGRP, the router, or ISIS, the router talk to each other. And they are able to learn. So of course, a small network is okay that you type, you complete the routing table with IP route command. But the internet, don't do that. The internet is so big, so huge. Okay, we don't do that in the internet. We let the router talking to each other. And look, the routing table of the router in the core of internet have more than 300,000 entries. You see this routing table, 7 entry. This is nothing. 300,000 they have, the ones that are in the core. So every time that a packet passes through one of these routers, the router have to compare it with 300,000 entry before it decides what to do with the packets. So a lot of work, as you can see, for each packet, and it's millions of packets that those router process in 1 second. So they do that millions of times, you know? Okay, so look at, can you tell me what is the difference with this exercise? So let me just keep the IP addresses, so we have a little more space. So the first question is with this IP address, then this IP address, and this IP address. So we can see both, maybe. Yeah. So what is the difference between the routing table that we have now and the previous routing table? Who can tell me what is the difference? We still have the 3SEM-C entry, and we still have 3 S entry that have not changed, but there is one S entry that is different. In the previous exercise, for all the subnet of 204, we have a /24. Look at here. We have a /23. What does it mean? What are the IP addresses that are inside this network? Give me the range of IP addresses in this network. What is the first IP address? What is the last IP address?
SA/23 or 25?
23.
So we're at 4, 5.
So what will be the first one?
450.
The first one?
200-4-4.
Okay, that will be the first valid. The first one will be 200-440. Okay? I cannot use it. So the first valid will be 200-441. That's true. What will be the last IP address?
525.
Good. So look at the difference. Previously, we were telling with two different instructions. We were telling R1. If you want to reach the network 200-440/24, which is this network, send it to R2. With a second instruction, we were saying, if you want to reach the network 200-450/24, send it to R2. Now we are saying with only one instruction, if you want to reach any of these two remote network, send it to R2. Because we are saying all the IP addresses that are between 200-440 and 200-45-255. So in this group of IP address, we have 512 IP address. When we say 200-440/24, we have 256. And when we say 200-450/24, we have the other 256. 256 plus 256 is 512. So here we put only one instruction, and with this instruction, we put these two networks inside. Of course, we can do that because it's the same thing that the router have to do. Since the router have to do the same thing, we can just say, instead of putting two different instructions, we kind of factorize and put a big network that include these two networks, and just tell the router, okay, for this big network that include these two sub-network, just send it to R2. So we make the routing table of the router a little smaller, which means that every time that the router have to process a packet, now you don't have to compare it with 7 entries, but with 6. So what we did with the router of the core, we did that to make the routing table a little smaller. Even if we did that, they still have 300,000. But if we didn't do that, it will be 700,000. So we went from 700,000 to 300,000 because we try to create less entry as we are doing in this exercise. We create less entry. Of course, if, for example, you say, okay, to go to Paris, you take this route. And then you say, to go to Toulouse, which is also a city of France, you take this route. And then you say, to go to Bordeaux, which is another city of France, you take this route. Why don't you tell me to go to France, take this route? This is exactly what we are doing there. We are saying, okay, if you want to go any city of France, the way is there. Any city of Italy, the way is there. Instead of saying to go to Rome, to go to Pisa, to go to what other city of Italy we can use? Venice, okay? So instead of giving a lot of details, we give a global information. Now, when I arrive in France, I need more details. But when I'm in the USA, I need to travel to France. Don't give me the details. Okay, I need to take a plane in Atlanta and land in Paris. This is what I need to do. Don't tell me that there is a small road there in Paris that at this level I don't need this detail. So it's what we are doing. The router that will have more details about the map of Paris of France is the router that will cover France. But far away from friends, it don't need to have too much detail. It's why we try to simplify the routing table of the router so they manage the routing faster. Okay, so let's see this exercise. What will happen if the router receives a packet on the destination IP address is 204.522. So let's see. Is this a match here? Is this IP address belong to this network? No. Does it belong to this network? No. What about this one? No, no, no. What about this one? Of course, yes, one match. What about this one? Of course, yes, two matches. So which one is the smaller one? This one, the one that I have here, highlighted. This IP address belongs to the 204.40/23 network. So I should send it to 10.0.0.5, which means I should send it to R2, as we can see. There will be a recursive search, and the router will find that you have to send it out fast Ethernet 1.0. Okay? What about this IP address as a final destination of a packet? So the same thing, the router check this entry, no match. Check this entry, there is a match. Check this entry, no match. No match, no match. There is a match, no match. To two matches, this one, this one. I go with this one. This one tell me if you want to reach this a device that belongs to this network, you have to send it out to a next hop, which is 10.0.0.5. 10.0.0.5 is also R2. So I will send it to R2. Of course, R2 will send it to the device that are here in this local area network, no? What about this one? 10.4.6.40. So there is a match here, no match, no match, no match, no match. There is a match here, no match. Two matches. Look at this is a /0. This is a very big network. This is a /24. This is a smaller network. The smaller it will be a /32. The bigger will be a /0. A /32 have just one IP address. A /31 have two IP addresses. A /30 have four IP addresses. Okay, a /24 have 256, for example. So it will do what this entry say, and this entry say send it to 10.0.0.2. So with a second search, the router will realize that you have to send it out this interface to 10.0.0.2. Okay? Look at this also work. So let me check a little this last possibility. So what is the difference here? There is no modification at the level of the C. Now look at what we have here. We have a /22. Tell me what are all the IP addresses that are here. They go from where to where? This is a very nice exercise. So let's remove that. Okay, there is a question for this IP address. Okay, so we can see everything. This is a /22. What is the first IP address in this network? Okay, the first valid. But the first IP address will be 200.440. Okay? What will be the last IP address? not .8, .7. So we have 4, 5, 6, and 7. So they go from 204.40 to 204.70, 7255, sorry. So look at this entry say any IP address that is of the type 204.4 or 204.5 or 204.6 or 204.7, send it to 10.0.0.5. Who is 10.0.0.5? R2. So it say any IP address of the type 204.4, 12. I send it to R2, good. 204.5, 12. I send it to R2. 204.6. This entry also says send it to R2. You see? 204.6 is here, but this entry says send it to R2. On 204.7, it says send it to R2. So we can say, there is a problem with 204.6. If the destination is 204.6, I should not send it to R2, but I should send it to R3. So let's take this example and see what will happen. So the router have to send something to 204.6 for T. So it starts. Is this the match? Yes, good. Is this a match? No. Is this a match? No. Is this a match? No. Is this a match? Yes. Is this a match? Yes. 3 matches. So which one is smaller? Here we have a /24. Here we have a /0, and here we have a /22. Which one is smaller? Thank you, the 24, which means that the router will do whatever this entry say. And this entry say, if you want to reach the network 204.60, send it to 10.0.0.2. So it will send it to 10.0.0.2. Bingo. You see, these entries say also, if you want to reach 204.6, send it here. But it have a lower priority. Since it have a lower priority, the router will do the correct thing because it will use this one. Because if you look this entry also, say, if you want to reach 204.6, send it to the internet. But we use this as the last resort, which means that if there is no other entry. And here there were 3 entries. The one that have higher priority is this one. If this one were not in the routing table, I will do this one, but it is in the routing table. And this one say, oh, I have priority over this one. So I should do that to reach the network 204.6. So it's why the routing table at the end is correct, because we have priority. It's like you want to go to France, and somebody that you trust a lot tell you, oh, you want to go to France, so you go to Atlanta and you take a plane to Paris. And somebody that usually lie at you or is much less reliable tell you, oh yeah, you go to Atlanta and you take a plane to Bogota. Well, if you have somebody that's reliable that give you an information and another person that is not that reliable give you another information, you will go with the information with the person that give you information that is reliable. The same thing here. Doesn't mean that you cannot go to Paris through Bogota, but you are going to spend much more time because you are going to do much more kilometers because you are going to go south because Bogota is south, and then you are going to go north because France is north. So why don't you go north from the beginning? Okay, but the same thing happened here. Orientation, just map for router. Okay, do you have any question? No? So remember, you use the computer on the university, just 2 applications on your computer.